Start recording. All right. So yeah, I just like to record the lectures so that y'all have an opportunity to go back and hear what was said, or if you weren't here. Uh, anyway, we're all set now. It's recording. So today we're going to be talking about the second topic here, manipulating GIS data and overlay. So I'm going to go through a PowerPoint presentation, and I'm going to go over Model Builder a little bit, since we're going to build a little model today, and then I'm going to do we're going to talk about this exercise. I'm actually going to do some of the exercise as I go through the content. And then I'll introduce it. We do have some readings for this week, so you may or may not have gone through those. I forgot to introduce that last week. You're more than welcome to go in and read ahead of time. Some of these readings pertain to what we're doing today, basically the first few, and then the readings on spatial join, that's what we're going to talk about the bulk of next week. All right, so there is another reading for next week, but you can read that as well. All right, so one of the things that we're going to do today is work with some data. This will be part of, I'll talk about it during the lab and during the lecture. And in exercise 2, I have a link to this data right here. So, anybody been to Maris before, this website Maris? Okay, good. So, you know who runs this website? This website's actually run by by an arm of the Institutions for Higher Learning. So it's run by the universities in a way. There is another GIS outlet, GIS data for Mississippi, that's run by the state. Yeah, it's right here, Mississippi GIS Data Clearinghouse. And they do have a lot of overlap in the data that they have. So this is run by the state, directly by the state government, and Maris is run by the Institutions of Higher Learning, like I said. Okay, but they both have a lot of generic GIS data for the state. And today, what we're going to do is this is actually a link to one of the pages that's down a little bit. So this is the main home page for Maris. We're going to download some county data. Now, it doesn't actually matter which county data you download. All of these county data zip files look exactly the same inside. In other words, what they contain are a bunch of GIS layers for the county, and they all contain the same GIS layers for the county. So in the lab, I explained that I would rather you pick 3 counties that that border each other, but yeah, so, but you're free to pick any 3 counties that border each other. So for the coast, you know, it might make sense to select Hancock, Harrison, and Jackson County, since they're right next to each other, and they're the 3 coastal counties. If you guys want to up here want to do Forest, Lamar, and Perry, or Forest, Lamar, and Marion, those are 3 contiguous counties. Okay, that's all I was trying to say. So I'm going to go ahead and download Forest, which is the county that we're in, and I'm going to download. I should download George County, right? That's my name. Just kidding. What is my name? Lamar, and there's Marion. So I got the 3 counties from Columbia into Hattiesburg. So if I look at those in a folder here, in my folder, I'm gonna sort these by date modify. So I've got Marion, Lamar, and Forest. And these right now they're compressed zip files. In other words, they're a single file that has a bunch of files inside of it. So if I click on this, Marion County, I see that there's a folder inside of the zip file called Marion. If I click on it again, there's a bunch of files in there. Okay. Now, Windows is letting me see inside this archive. Right? These files are not unzipped. It's not possible right now for ArcGIS to see into this zipped file. It can't do it. And so I need to unzip these files in order to work with them in a GIS software package. You probably you've done this before in another class to do that. There's lots of different ways to unzip. One of the ways that I can unzip is that I can simply right-click and copy. Right-click on the folder inside of the folder. Right-click and say copy, and then paste it to a location that I want to use it in. I'm going to do that. I'm going to go in the C drive, and I'm going to create a new folder here in the C drive. You probably can't do that on the C drive on your computers, but there is a D drive on your computers. Maybe there is. I forgot. You could create a new directory. You'll definitely be able to create a new directory if you go inside of users and then you select your name from this list. Okay. I just put it right there under the C drive. I'm just going to call this VG for Vector GIS class. I'm going to put a new folder in here and call this Lab 2 because it's really kind of Lab 2. And then I'm going to put Marion County in there. So now I've copied Marion County in there. So you can see under Vector GIS, Lab 2, I've got a folder called Marion. I can do the same thing with both of those other files. So I've got, I go back under downloads, this PC downloads. There's Lamar. I pull Lamar, right click, say copy, and paste it under VG Lab 2. Paste it right next to Marion. So now I have Lamar, Marion, and Forest was the other one. Okay, if I don't do this, ArcGIS won't be able to see those data. So I've got 3 of those files. Okay, and we're going to be using these inside of ArcGIS Pro. So if you want, you can go ahead and start up ArcGIS Pro. You can either do that, or you can just follow along with me and go back and do this later. But this is what you see when you first open ArcGIS Pro. And for those of you who aren't familiar with ArcGIS Pro, it's a little different than ArcMap, primarily in the way that, I mean, obviously the buttons are in different places and things like that. But one of the primary differences is ArcGIS Pro is what we call project-based. Or not what we call, what ESRI calls project-based. And so when you open ArcGIS Pro, by default, what it wants to do is create a new project for you. And that project is going to contain, it could contain multiple maps, and it could contain your data. It actually just contains links to your data. It doesn't contain the data itself. It contains links to the data for a specific project. And you can have actually as many maps as you want, or as many maps and scenes. Scene is like a 3-dimensional GIS thing, the GIS display. So in ArcMap, it's what ESRI called map-based. In other words, every ArcMap document, it was called a map document, was about creating a single map. And so you could create a single map that has multiple, I'm going to say maps, but multiple, like a map with a submap, but it was all just one page that you were designing on, and that's different in it's different in ArcGIS Pro. So when you first open it, it's going to ask you to create a new project. And what do you want in your project? Well, I want to put a map in my project. That's usually what you're going to select, is a new map project. And so I clicked on map, and here's where it's going to save it by default. That's the location that it's going to save your map project that it creates. I'm going to change that so that it puts it in the same location that I put my data. So I'm going to hit this little button and go to C, VG, Lab 2. I'm going to put it right there in Lab 2. Okay. I'm even going to call this project Lab 2. So there'll be a new file that's created inside of Lab 2 when I hit OK. So right now, let's look inside Lab 2. There's nothing there except for the 3 folders that I put there. Now, as soon as I hit OK, it's going to create a project there. Let's look at what it created. So it created a folder called Lab 2, and inside that folder, right now, there's not anything. There's going to be some stuff once it gets done and once we start doing things. It's almost like I should have just put the project one level up, but it's okay. So now I have a Lab 2 folder inside of Lab 2, which isn't a problem. But here's all of the files that get created as part of a ArcGIS Pro project. Okay, what do those files look like? What's that little red icon?
Toolbox.
It's a toolbox. So by default, every time you create a project, it creates a toolbox. It just does it. ArcGIS Pro creates that. If you want to design any custom tools, which we'll be designing some custom tools, that might be the best place to put it, right inside the custom toolbox that it creates for you. Right? Then this is the project file itself. That's all that is. What is a .gdb file? Anybody know? It is. It's a geodatabase. So it creates a geodatabase for you, and Windows sees a geodatabase as a folder. That's why it's showing you that as a folder. You go inside of it, and it's not human readable. Okay, but this information here is the information that's inside of your empty geodatabase. We're going to put some stuff in there, but right now there's nothing in there. Okay. You can see the information that's inside of that geodatabase inside of ArcGIS Pro if you go to view the let's view the catalog pane or the catalog view. Okay, there's the catalog pane. So here's the catalog pane. If I go under databases, here's my empty Lab 2 database that ArcGIS Pro just created for me. It doesn't have anything in it. Now here's the Lab 2 folder that it created. I think what I might do here is actually take these 3 data folders and cut them and paste them into here. So now they should, if I refreshed this, they should just show up there. So that Forest, Lamar, Marion, they show up there. I probably should have created my project first, then brought the data in, but now I've got this kind of weird Lab 2 thing. We'll just live with it for today. Yeah. All right. So I'm going to save it now. I've got everything set up. So I've got my geodatabase with nothing in it. I've got a bunch of data sets here inside of these 3 folders: Forest, Lamar, and Marion, all in the Lab 2 folder. Okay, I'm going to add some data in. Actually, maybe, well, I'll do this and then we'll start the lecture up. I'm going to add in the water bodies for each of the counties. So I click on Forest and I go to the water body layer. I'm going to drag it onto the screen. So now, it might be a little bit hard to tell. I'm going to change the background by going under Map, and under Base Map, I'm going to choose something that doesn't have a lot of noise in the background. Either the dark gray, I think I'll go with the dark gray canvas. Yeah, that's what I'm going to do. All right, so you can see the water bodies over the dark gray canvas here. See all those water bodies? Now I'm going to go to Lamar and add the water bodies in. I'm sorry? Oh, okay. Under Map, Base Map, I changed it to dark gray canvas. So that is something new about ArcGIS. You can actually add a base map in ArcMap, but by default there isn't a base map. In ArcGIS Pro, there's a base map. And you can delete it. You can go over here and right-click on it and just say, I don't want a base map anymore, remove it. But I guess the folks at ESRI thought it'd be helpful to have. So then I could go under Marion County and get the water bodies. Okay. So I've got water bodies in all 3 counties. Notice, though, if I zoom in here, do you think that these are 2 different water bodies? No, those are created because these were originally chunked out by county from whatever data source they were created from. It looks like the National Hydrographic Data Set. That's what NHD stands for. So, created by the federal government. These are the data sets that are created to go on to lots of their different map products. I don't know if there's too many cases where the county boundary, well, that doesn't really straddle the boundary because it looks like there's a roadway in between. Anyway, it looks like that was the only one. But in all of these data sets, they have the same issue where there are things that straddle the boundaries, but there aren't there are entities that straddle the boundaries, but they aren't really different entities. Okay. All right, so let's go through and talk a little bit about the other items that I want to discuss today, and then we'll come back to that. Didn't. All right, so today we're going to talk about creating and manipulating vector GIS data. I do like to walk around, but I need to get a microphone that's clipped to me so that I can do that. Because right now I'm limited, so that's why I'm sitting at the desk, sitting at the desk here. But this term geoprocessing is a little bit of what some people might refer to as a loaded term in GIS. So geoprocessing is a term that the ESRI kind of co-opted, I guess you could say. In fact, when the earlier versions of ArcGIS came out, particularly ArcView. ArcView was the first kind of desktop GIS that was available that had a GUI interface. You could press buttons. And when it was first created, ArcView was really all about viewing your geographic data and making maps with your geographic data. And if you wanted to actually manipulate your GIS data, you used a commercial product called ArcInfo. It was a product that initially ran on bigger computers, and then they eventually did come up with a PC version of ArcInfo, PC ArcInfo, but it was literally like a command line. You typed in your commands, and then it did it, and then it had a programming interface called AML. It was really, well, it stood for Arc Macro Language, and you used that if you wanted to do overlay. That's when I first started getting into GIS. That's what I did. So anyway, as ArcView developed, they started putting in some of the abilities that ArcInfo had to do data analysis, and they called this tool that could do GIS processing inside of the GUI. They called it the geoprocessing wizard. Okay, and so that term kind of stuck as the way to do GIS analysis. And doing GIS analysis, because ArcGIS, ESRI had such a large control of the market, geoprocessing became synonymous with doing GIS analysis. But it really should be widely applied to any attempt to manipulate GIS data, whether it's done in ArcGIS or not. The tool started out with buffering. Buffering was the very first tool that was in the geoprocessing wizard, and then overlay was included. And those are what we're going to focus on mostly today. But ESRI slowly created this humongous list of tools that we can manipulate GIS data with. And I'm sure in your previous courses you've had some interaction with lots of these tools. So that's what we're talking about. All right, our toolbox was created about 10 years ago, released in May 2009, and toolbox is a container for all of these tools that ESRI originally started including in the geoprocessing wizard, and then when they released ArcMap, the first version of ArcMap, they released a separate standalone application called Arc Toolbox, which kind of organizes the very long list of tools that they had started to create and include in the geoprocessing wizard. Shortly after our toolbox was released, they they released a tool for chaining these tools together, and they referred to that as Model Builder, and we still have Model Builder today. Okay, so it's a way to automate a GIS workflow. You could say, run this tool, and run this tool, and give me a result. So we're going to talk about some of those tools today, but also talk about why we would use them and the concept behind those tools. So it's kind of a review for those of you who have taken a GIS course, but this will be helpful, and then we'll get into some more advanced tools and analysis as we progress down the course. All right, so one of the tools that exists that's a very simple tool but powerful. It allows us to do important things. We talked about this a little bit last week, so I won't spend a whole lot of time on here. But if I want to take information from an existing vector GIS layer, and I want to take only records that I need out of that layer based on some criteria, then that's called a select. So here an example, a city planner might choose to perform a select on all areas that are zoned residential. Okay, because I as the city planner might be looking for areas to put a new housing development. Okay, and I only want to look at those areas that are zoned residential because those are the only potential candidates. Okay. Now, selects can be spatial in nature. They can either operate on the attributes, or they can operate on the spatial information. So I could say I want to select all of the entities that are within a certain distance of another entity, and that's another type of select. So in most GIS systems, ArcGIS being one, either ArcGIS Pro or ArcMap, there are a few ways to do in the graphical user interface. There are a few ways to do a select. Okay, so one of the ways to do a select is to do it in the toolbox, and that's the way that we're going to do. But you could also do it under Map. You could say select by attributes. What's really nice about ArcGIS Pro is that in ArcGIS Desktop, sorry, not the only thing that's nice, but one of the things that I like about ArcGIS Pro is that they have aligned the two tools. So there's still a button to do select by attributes, but all it really does is open the tool for you. Notice that it calls it geoprocessing. Right? So this is going to select a layer by attribute. So I could take the water bodies. Okay. I don't know which one of these is which. Looks like 91 is Marion County. So I can say I want to select the layers from the Marion County water body file, and I want to do a selection. Now, there are a bunch of different types of selections I can do. I can create a new selection, which is a default. I could also add to the current selection if there were already some of those items selected. I could switch the selection, clear the selection. I'm just going to hit New Selection. And then I have to put in an expression. Now, these expressions are actually written in a language called Structured Query Language. SQL stands for Structured Query Language. ArcGIS and some other applications actually hide the building of this SQL a little bit. So they kind of make it so that it seems a little less intimidating. But you can, if you want, look directly at the SQL. Right? That's what's kind of nice. So let's delete that and go back. Okay. So now if I hit New Expression, I can type in an expression. I could say I want, I don't know, the area to be greater than, I don't know, let's say this guy right here. Let's look at his area. The area is pretty big. What is that? 142002. That's big. It's probably in square meters. So the area is bigger than that. I'm going to delete the 0.8 so that it actually includes that. Okay. So that's my where clause. I can see what it looks like if I turn the SQL back on. This is what it looks like in SQL. So I can manually type it, like if I wanted to manually adjust it, I could say 5 and change back. Okay. I can chain together as many where clauses as I want. So if I wanted to say where the area is equal to this and some other attribute is equal to this and some other attribute is equal to that, I could hit this button and do that. So I could say the county name is equal to Marion because they're all in Marion. So that's not really going to affect anything. I can change whether or not it's an and or an or. I'm just going to leave this here for a second and run. Okay. All right. I don't know. I don't really know why all of that. So let's get rid of this. Maybe I deleted too many numbers. Because it's selecting every single thing. Where area is greater than. All those aren't. Oh, you know what? Let's look at the attribute table. All the areas are the same. So that must be the total area for the county. Let's do this area by square kilometer because those are different. So area square kilometer is right here. And then now I'm going to say greater than, let's pick a different one. Area square kilometer 0.04. Paste, run that guy. All right, so now I'm looking at only the larger water bodies in Marion County. All these little water bodies aren't selected. Okay. All right, so if I added back that other one and county name is equal to Marion, what's going to change here? What's going to be selected now that I've said and county name is equal to Marion?
Only the ones that meet the criteria that are in Marion County.
Right. Which they're all in Marion County, so nothing's going to change. Okay. What if I change this to or? What's going to change?
It's going to select everything in Marion County.
Yes, it's going to select everything in Marion County because the clause here is as it says it's either bigger than this or it's in Marion County, which is all of them in Marion County. So all of the records get selected. Okay, so that's a little demonstration of select, the where clause, and how it works.
Yeah, I think Dr. Raymond,
Yeah.
could you, if you in one building, reach over to the geoprocessing and drop into the middle of the page, still do the same thing?
Yeah, so that's that is true. That's what we're working towards here. We're gonna go to analysis model builder, and we could run this select by attribute tool because it is a tool. We could run that in model builder. Select layer by attribute. There it is. Whoops. And what you do is you actually just drag it on. So now we have that tool there. If we wanted to run the similar analysis, we would choose the water bodies, and a new expression would be not area. It was area square kilometer is greater than 0.04. Okay. When it changes colors like this, it indicates that it's ready to run. And we could run it. And now if we switch back to the map, we can see that it's selected just those. I just closed my map. I should have a whoops button. I don't think they do though. Huh. Actually, I think it's been a little while since I saved it. So I'll just load mine back on. Water body, water body, water body. Lamar water body. Okay, we're back in business. And then I'm going to rerun this tool. Analysis. Oops. Run. There we go. Oh, one thing is that it seems to have become, it seems like it's no longer in sync with the map. Probably because I deleted that other map that it was in sync with. There we go.
So if you delete the map, you have to revalidate the map, she just delete.
No, it's just that layer that it was operating on is gone. So I had to, what I really had to do was hit this button right here and choose the right layer. See, these layers are gone now. So I had to choose the correct layer, and that way I got an output. Now, what I could do to overcome that is actually choose the file on disk rather than the layer. So if I chose the forest, and so I've chosen a path. Anyway, all right. So I got those layers selected, demonstrated select. There are several tools that are called select. We've got select by attribute, select by location, table select, and a tool that's just called select. And they do something slightly different. I'll explain that right now real quick. Select by attribute virtually selects rows from a table and highlights them on the map for you. But it makes no change to your data at all. So in other words, there's no real output. What it does is it actually highlights them on the map and highlights them in the attribute table that's being displayed. Okay? But it doesn't save anything out on disk. We could, if we wanted to, right-click on this guy and select Data Export Features, and we would export just those selected features. Alternatively, if we just wanted to do those as one step, ArcGIS has created another tool for you to do that. Now, it wasn't necessary. It's just nice for convenience purposes. The select tool, what it does is it has input features and output features. So you can do the same thing where you select, Marion County here, and you choose an expression where area square kilometer is equal or greater to 0.04. And if I run this, it's going to save it into this new file. By default, that new file is going to be in your file geodatabase. So if I run this right now, you'll see that I've created a new, that's new. That wasn't there before. And if I turn off the existing layer, you can see that this new layer contains only those water bodies that met the criteria. All right, so what's the difference between the two select tools that I demonstrated in your own words?
Just the select makes an actual layer, so that's almost like when you would do on the old ARC map, like make a layer out of selected features.
Right. Yeah, both of these tools were actually available in the old ArcMap, but in ArcMap. But yes, your other statement was 100% correct. Select layer by attribute just selects them on screen. Select actually outputs a new file. Okay, so you might need one in one time, one in the other. Select layer by location, we'll cover that later, but it's basically selecting based on a spatial relationship. And then table select does the same thing as select, but for a table instead of a GIS data layer.
So select to change the input or the output, correct?
the plain old select, it also doesn't change the input. Neither tool changes the input data set. So select layer by attribute highlights it on screen, but as soon as you close ArcGIS, the data is the same. It's just highlighting it for you inside the application. And then select doesn't change the original data either. It just pulls out those records that meet the criteria and puts them in a new layer for you. By the way, what format are these data in that are in the folders? Right. These are in shapefiles. And a shapefile is a pretty old format now. It's 15, maybe even a little bit older than that, almost 20 years old. Yeah, actually about 20 years old. So shapefile came out with ArcView. And a shapefile is a file that actually it's called a shapefile, but it's a little bit of a misnomer, because if you can see that all of these files together make up a single shapefile. All right. And a geodatabase is a newer file format, and the output was saved by default into the geodatabase file format. And a geodatabase on disk looks like a folder. We already discussed that. Okay. But I can't see my NHD waterbody 1691 anywhere in here. It's not in there because it's inside one of these files. The data is all it's not human readable. Sorry, what's that?
I thought I saw something that looked similar on the bottom of that. My own previous order.
Oh yeah. So there's a little there's a lock file, and what this does is it's because I have ArcMap open. It's telling me how this data is being used. So it's being used in this file, and it's being used on this computer. So that's what that's telling me. If I close up ArcMap, this file would actually disappear, this locked file.
Oh, okay.
All right. Or if I remove this, I'm going to remove this layer I just created. Well, actually, I think it might still show up. Nope, it disappeared just by doing that. Okay. All right, so SQL syntax allows you, it differs a little bit depending on your data source, so just keep that in mind. So if you're using a file geodatabase or a shapefile or even an enterprise database, in other words, a large database like Microsoft SQL Server or Postgres SQL, there's slight nuances, changes that you'll have to make. ArcGIS Pro handles those differences for you. So if you're building an SQL statement and you press on the buttons in the query builder expression, it will know where the data is coming from and handle those for you. So they have their own little SQL dialects though. So to query file-based data, including file geodatabases, then you'll use ArcGIS SQL. To query enterprise geodatabases, you'll have to use the dialect of that underlying database management system, of which we'll use Postgres SQL in this class a bit. All right, review of table terminology. We've got rows and columns of data. The rows are referred to as records, and the columns are referred to as fields. We can have standalone data in our GIS. We can use standalone data. We refer to standalone data. We refer to data that's not standalone data as an attribute table. In other words, it contains information about the features. What about this field right here? This first field. It says FID. Do you know what that's always in there? What's FID stand for?
Field ID.
It stands for feature ID number. And so in a standalone table, you'll often see it called OID or object ID. One of those two. Which stands for object ID because it's not associated with a feature. All right, so we talked about select. The next thing that's useful to manipulate vector GIS data is the ability to calculate, to do calculations inside of our tables. Right? So we have our attributes here. If we want to create a new attribute, then there's a tool for that. Let's just call it add field. I want to add a new field. I want to add a new field to my, I'll do it this time to, well, let's do it to the Lamar County. So that's 73. I'm going to make a new field called area underscore square miles. Area underscore SQ miles. And we're going to make this, we have a choice here. We can make it text, double, short, long, whatever. We're going to make this a double. What that means is it has a decimal place, and it's a more precise decimal place than a floating point number. You can leave these blank, but this basically says, okay, how many places do you want after the decimal, and how many decimal places do you want total? Oh, okay, so look at the error there. The length of the field name must not be larger than 10. Has anybody ever seen field names that are larger than 10 characters? Yeah, that exists.
Yes.
But not inside of a shapefile. Shapefiles, it's an old data format. One of the restrictions that they placed on it was that the field names couldn't be longer than 10. So I've got to change this to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I guess you just got to do MI. If I just did M, people would think it was meters. So I'm going to do MI and run it. Okay. So I've got my area square miles. I'm going to right click on it and say calculate field. But again, in ArcGIS Pro, this is just activating the tool. I could have also gotten to that tool by saying calculate field down here. All right, so I want to convert the column that says area in square miles, or sorry, the area in square kilometers to square miles. So to do that, I could choose the 73 database, choose the field name that I want to store my new values in, which is the one I just created. And now I can build an expression that will calculate the area in square miles based on a current value. So here I can say area in square kilometers times, which is the asterisk sign. What's the conversion between square kilometers and square miles? Well, I need Google to help me there. Square miles. So 1 square kilometer is equal to 0.386102. So I just multiply my number of square kilometers by that. And now I have a new column that tells me my area in square miles. See? All those are the areas in square miles of all those water bodies. All right, so that is calculating.
If it's
Can you show the syntax that you typed in?
Sure. Sorry, were you about to ask a question too?
I was trying to see exactly the areas where miles
I double clicked on the area square kilometer right here so that it would build that for me. It's an exclamation point. Exclamation point area SQKM exclamation point.
Click on,
and on the other side, that's just where you put the asterisk for times.
Asterisk and then,
the
yeah.
size.
Yep, exactly. And this is technically a little Python code snippet. So the other class I'm teaching this semester, we're learning more about Python, but this is just a little code to calculate that value out. So it goes through there and applies that code to that. You can choose a few other languages. Arcade is a language that that ArcGIS, the ESRI, invented, and then SQL is a structural query language that we covered before. The default is Python. Okay. What's that?
What would the square kilometer look like?
I'm sorry, I can't hear
More
you.
than 380.
that's the,
What's the conversion?
Yeah, but I mean, that's 1 kilometer to every mile, right?
That's kilometers to miles, and so this is kilometers. So let's just say that that the value over here in area, so it's way over here, would be area in square kilometers was 1. Well, if I multiplied it by that number, I get that number, which is the correct value.
I guess what my concern is like the 3 8 on Google.
When you put in 1 square kilometer,
1 pound.
Yeah. Yep.
One.
All right, now you can actually, so we calculated based on this other field, we converted kilometers to square miles. Oh, but ArcGIS actually allows us to, I got to clear the selection, otherwise it'll just operate on the selection. ArcGIS actually allows us to calculate based on the geometry of the feature. So we can right-click on area per square mile and say calculate geometry, and we get a different tool. This tool allows us to go in, and instead of calculating based on another field, we want to base it on a property. So we're going to say, let's base it on the area. And the area unit that we want to choose is square miles. It says square miles United States. We're the ones that use miles most of the time, but there are actually a few other places that use miles or might want to use miles. Okay, so I've got that, and this will do an equivalent statement. When I run this, I don't know if these values will change that much, but now I'm calculating from the actual geometry into those values. Let's see if they change. They probably might change a little teeny bit, just because I didn't really notice any. Oh no, they changed quite a bit. So some of these calculations weren't exactly right, but that's based on the geometry themselves, not on the attribute. So we can calculate all sorts of things based on the area. We could based on the geometry. We can calculate the length, calculate the number of parts, the number of vertices. We've got a lot of things that we can do, and we'll look at some problems this semester that might be trying to get at some of these other things like the length of the area. All right. So you see the difference between those two. One is actually taking the value from another field and converting it, and the other one's looking at the area and calculating the area. Calculating the area is actually not that difficult. I mean, it's just a mathematical formula, and it might take us a few minutes to do it with a calculator, but we could look it up online, calculating the area of a polygon. But ArcGIS does it really quickly because the formula is already stored inside of the computer code. ArcGIS, inside of a geodatabase, let's go back over and show, here's a geodatabase, right? If I open up this geodatabase, if I put this layer back on here, I deleted it earlier, and I look at the attribute table, one of the things about geodatabases, whether they're file geodatabases or enterprise geodatabases, is that they will always have these two columns at the end. So they'll always have the shape area and the shape length already as part of the table. So they calculate these things automatically and append them on to the end of the layer. Shapefiles don't have those. Okay, but just so you know that that's there, and it's always in the same units that the data itself is in. How do we find out what units the data itself is in? Yeah, the metadata. We can right-click on this guy, go to Properties, and look at the, probably under Source, yep. Spatial Reference. So right here, under Spatial Reference, we can see that this is, linear unit is meters. So these are in square meters. That's why they're different than this guy right here in, we asked for it in square miles. But they'd be the same if we said square meters. So shapefiles don't create or maintain those area length fields automatically. You have to create them manually, like we just did, and you specify what units you want them in. They aren't just by default the same unit that it's in. Okay. You have to be careful because let's say you're dealing with, let's just say I do something very simple. Let's say I take one of these cells. Let's say I take that water body and I edit that water body and I split it into two water bodies because the area in between dried up. What happens to the attributes in that case? What about the area attribute? Does it change? Does it update automatically? No, it doesn't update automatically, especially if it's a shapefile. Now, if it's not a shapefile, if it was a file database, these two fields do update automatically. So you have to kind of know what you're dealing with. If you're dealing with those two special fields at the end, you're good to go. You have to know what units they're in, but those will update automatically. But any other field, even if I name that field area, it won't change. Now, that applies to everything about the attributes. So let's just say we had another field that said duck population, and the duck population was 50. And I cut that in half and made two different ponds. The duck population of each of those attributes would still be 50. So I like doubled the duck population in those ponds. Not really. That might seem like a silly example, but let's say that these were census units, and they were census tract, and it had 1,000 people in it, and I cut it. No longer has 1,000 people in it. The current polygon. So when you edit things, and we'll talk about doing some editing and analysis. Let's say I did an overlay. I overlaid a census unit of a certain size with another thing like maybe a county boundary. If I overlaid those two, I chopped off part of it, and I only had part of the census unit left because of an overlay operation. Some of those attribute values no longer make sense. So that's something to keep in mind when you do overlay, is that your attributes don't change, but sometimes your spatial extent changes, and it's no longer representing the same attribute. Sometimes you need to compensate for that. So anyway, back to the original message here is be careful about the area, length, perimeter fields in shapefiles or in other data sets. All right. So this is the old screen. This is how it looks in ArcMap, but you saw the new screen that I just did. Should have updated that. I'll update it after class. But you can see these are the same slides I used last year. All right, another geoprocessing operation, a basic geoprocessing operation, is called dissolve. Right? Dissolve, they combine adjacent polygon features into a single feature data set. Now, let's think about a table. Let's just say that we had, let's go back to last week's example. Let's say I had all of everybody in here. You're in a table. I do have a table like that. Everybody's in here, and then at the end of this, after the first exam, I had everybody's exam score next to their name. So that would be a record with everybody's name and their exam score as one of the attributes, right? And I wanted to calculate the average of the graduates and the undergraduates. Okay. That operation, I want you guys to think about doing that operation as the same thing as a dissolve. But instead of doing it as graduates and undergraduates, we're doing it we're doing it spatially. We're combining the people that share similar attributes that are also next to each other into a single record. And when we do a dissolve, we have to specify what the new attributes are going to be based on some summary statistic. So just like my example with graduate students, if I take all the graduate students, I want to find their average score. What's the summary statistic in that scenario? It'd be the average, exactly, right? So it's the average. So you have to think when you do a GIS operation, what is it doing with the geometry, and what is it doing with the attribute information? So look at this. We've got our input and our output here. Our input data sets look like this, and these categories might be, let's say they represent the predominant crop in that area. I don't know. I'm not sure what they do in this case, but they represent the predominant crop in each county. Those are county boundaries. And so if I want to do a dissolve, I'm going to say, I want to take all the counties that share the same predominant crop, and I'm going to output them as a single feature in my output data set. So that's what you get there. But what happens to the data underneath? Well, you also have to specify what you want to do with the data underneath. So, and that often is driven by the answer that you want to get, or it's driven by the question. So let's say you want to find out, I want to find out how much livestock is in each of these different predominant crop growing areas. And so I would have to choose that I want to dissolve based on the attribute that shows what? The crop type. And then I want to summarize my data as the either the total, probably the total amount of livestock in each of those counties, and then I could do something with that information.
I have a quick question.
Yeah.
See how on the example there's two green sections that aren't touching, so would they be in the same layer since they, let's say they do a medium amount of livestock?
Yeah.
Okay, so they're the same layer.
They're the same feature.
Okay.
Yeah, that's actually the default. You can say in most GIS software packages you can treat those differently or the same. So you could say, oh, here, let's just do this real quick. All right. So what I want to do, well, I wanted to discuss. Well, here, I'll just discuss the other one as I'm doing it, and then we can skip it in the slides. All right. So the first thing I'm going to do is I'm going to run a tool that's called merge. Okay. Let's see what merge does. Merge combines multiple input data sets into a single new output data set. I also have to get rid of all the, I'm going to go to map, and I'm going to get rid of all the selections. Clear the selections. All right, so I've got my original 3 data sets here. And what I want to do is I want to take all the water bodies, whoops, that's what I meant to do. I'm going to take all the water bodies from all 3 of the counties that I'm dealing with. If you're dealing with the different 3 counties, do different one. And I'm going to merge them into a new data set. All right, so I've got all 3 of my counties there, and I'm going to put them together into a new data set. And you can see this this merge rule here. Oh, I forgot I should sit down. Okay, you can see this merge rule here. What it does is it decides if there are different attributes, how I'm going to map them together. Now, luckily, these data sets were originally all one data set anyway. So when they get united, they can kind of figure out because they have the exact same names. But let's just say I had one data set and I had a county. One said county and one said county name and one said county CO name. I could come in here and say, oh, those are really the same. So that's what I could do with this field mapping data set. Now this area square miles is only in one data set. If I don't want to put that in the output data set, I just remove it. So now that won't be in the output data set. So what this is going to do when I hit run here is it's going to put all of these data sets into a single data set. So now if I turn these other 3 off and I zoom in here, you can see just turning this on and off, that's all one data set. The only problem here is that, look what happened. See that it merged them all together, but it didn't fix the county boundary issue. All right, so that's where we're going to get to a dissolve. We're going to remove this boundary. And the way that we're going to do that is through a dissolve. So I'm going to hit dissolve. Got my caps lock on for some reason. So we're going to choose the water body merge as our data set, our input data set. And I'm going to rename this output data set. I'm just going to rename it dissolve. All right, so we've got a few more parameters. These are called parameters. We've got a few more parameters to deal with. The first one here is the dissolve fields. In other words, if this field has the same value, what it's going to do is take the value from that field. Take those 2 data sets and combine them into one. Take those 2, sorry, not data sets, take those 2 features and combine them into one if they have the same value here. So in order to get these two boundaries to change to get rid of this common boundary, let's see what we have to do. Let's look at all of the attributes of that data set. They should all be the same as this one, except for things like the county name, that sort of thing. But is there anything that's the same about them? About this data set, about this polygon and this polygon? Object ID is different. Look at this. FID underscore NHD watt. I don't know what that is, but that appears to be the unique identifier for that water body. See what I'm saying? So if I click over here, I get a different number than I click on that one. So my guess is that if we use that, not my,
Object ID stays the same too.
what's that?
It looks like object ID stays the same too.
Where's object ID?
Yeah, it's not below
Object ID 1?
just,
The one underneath.
Oh, object ID right there.
it stays the same, so.
Yeah, that stays the same too. You're right. I didn't realize that. Yeah, we could probably use that one too. So I'm going to choose the FID underscore NHD watt. So what that's going to do is anywhere where it sees those data sets, anywhere where it sees that those two numbers are the same, it's going to merge those into a single feature. All right. So to get back to Ashley's question here, this button right here, this option right here, create multi-part features, if that is unselected, these two will become the same feature because those are, if that is selected, these two will become the same feature. They'll just be a multi-part feature. If this is unchecked, these two will become different features. So if this is unchecked, they have to physically touch. If it's checked, they just have to have the same value in this field. Does that make sense?
Okay, so if you were doing something like land cover, you would want that checked because you could have the same type of forest in two different spots.
Well, it would actually depend on the question you were trying to answer. Like if you were trying to ask the question, okay, how many trees are in each stand, then you would leave that unchecked because you would want to have each individual stand be the standalone. If you wanted to say how many trees are total in all the forests of this type, then you would check it. Good question. All right. Now the statistics field allows us to summarize any of the other attributes. So for example, we might want to summarize the area in square kilometers. And if we choose the sum, it's going to give us the total of all of the square kilometer areas that it joins together. We also can just choose we could choose a categorical variable if we wanted to, like county. Doesn't make a whole lot of sense here, but a county is a number, even though it really is a category. So that's kind of, see how category is a number? We don't really want that to be. We could choose county name and just choose, if it's a category, sum is an option. It's not really an option in real life because this is county name, Lamar. How do you get the sum of all of that? We could choose the first. So in other words, the first one that it experiences, it'll choose that. I'm not even going to put that one in there. All right. So I'm going to run this.
Isn't the area square miles the same for each, like, because of that, the way it was forwarded? Because one of mine, it looks like it's the same and they're not the same size.
I'm choosing the area in S cubed kilometers, not the area in square miles. See, these are all different. So I'm going to run this guy. And what it should do is actually remove that. See how it removed that boundary? It's the same color. I'll go ahead and make this a little bit different color. Properties, make that pink. Why? Okay, so on the pink one, there's no boundary. On the green one, there's a boundary. And it's one, if you click on it, it's all one feature now. And see, the only attribute that gets carried through are the attributes that you selected. So that the dissolve attribute gets carried through, and then also the sum of the area in square kilometers gets carried through. Let's see if that's reasonable. So this one says 1.06. Previously, this one had a value of 0.53 plus 0.53. So what's 0.53 plus 0.53? Yeah. Now, is that reasonable? Is that real? No. So that's a logical error. The computer did exactly what we told it to do, but the logical error here is that we trusted the attribute to hold the square kilometers when it really didn't hold that. Okay. All right. That's dissolve. Append is kind of like merge, except for append takes file A and adds layer A and adds layer B into layer A. So it appends it. Whereas merge takes layer A, layer B, puts them together in a new output data set. So typically I run merge, not append. But they're both operations to combine data sets. They're not technically overlay operations. They're meant to be putting together data sets. So basically, it's taking. If we think about this as a table, which is one of the things I want you to take away from these first few weeks. If we think of these as a table, what's happening in merge? It's kind of what we did to this class. So we have people on the coast. They're technically enrolled in a different class than the people up here that are enrolled in the class. And I merged them in a canvas, so now I can see all of you guys in Canvas, and I still have an attribute that says which section you're enrolled in, so I know that you're on the coast or I know that you're in Hattiesburg. But I merged you together. So I didn't overlay the two classes. I'm doing analysis between the two classes data sets. What I'm doing is putting those two data sets together. That's what merge and append do. Okay. So typically when we do a merge and append, here's some rules that you have to think about. You want your tables to match precisely. If they don't, you have a lot of work to do in this in here. You know, you got a lot of work to do in your field map. You have to translate, oh, in this field, this attribute is really the same as that attribute. So that's a definition of what it is. All right, typically you want your data to actually merge to be next to each other. Sometimes you might have to adjust. This data set might be in a slightly different projection than this data set. The data might be different. All right. Okay, we've been talking a lot about some basic GIS manipulation. Now we're going to review overlay real quick. So we're going to learn about overlay and implement it in Model Builder. So map overlays, what they do is they combine layers into a single attribute. And we've got two categories of map overlay. One that combine the attributes. These are commonly what you think about when you think about overlay. So intersect and union, they actually combine the attributes of anything that overlaps in another data set. So think about that. We can't really do this same analogy we've been doing with people, where we said, okay, the people from the coast and the people from Hattiesburg, we're going to do an overlay because we need space to do it. So what happens though is that when an overlay occurs, any polygon or any line or any point that exists in the same space gets all the attributes from all the features that coexist spatially. That's another way to say that. So that's what happens in these type of overlay operations. They combine attributes. There are some overlay operations that don't combine attributes. And in those, order is more important. Basically the inputs have different meanings. One is the one that you're operating on, and the other one is the way I like to think about it. The other one's the cookie cutter. So the cookie cutter doesn't have any attributes associated with it in the output data set. We'll show some examples of this. All right. So overlay is one of the features that makes GIS unique. Okay. So typically we think about it as just 2 layers, but most overlay operations can actually be done with X layers or N layers, multiple layers. And they always have inputs and they have outputs. So here we could have geology and ownership and say, okay, who owns what in the output layer? Okay. So extraction functions are a little bit more like selects, but they're spatial selects. So I like to think of clip like a cookie cutter. So we're going to cut out things that, features, but the attributes stay the same. No attributes change when you do a clip. Same with an erase. With an erase, you are going to use one layer to remove the features that are underneath that layer from the underlying data set, but still no attributes are changed. So here's a clip example. I've got a data set that represents all of these roads, and I only want the roads inside this watershed. So in this case, the clip data set is the watershed, and the data set being clipped, the input data set, is the roads. And the output is this red data set that shows the roads that are within the watershed polygon. So when we do a clip, there are some attributes that are automatically updated. The feature length and the feature area, but only in file geodatabase. Any other attributes, such as the lengths of the roads and the areas that we put in there, those have to be redefined. Any user-defined attributes don't get updated when you're doing a clip or any type of overlay, actually. Okay. So, for example, if we have a road that has a length associated with it, we do a clip. If it's in a file geodatabase, that special column that's called, not this one, open this attribute table. That special column that's called shape underscore length gets updated automatically. But if there was another field called length, it doesn't get updated automatically. And so all of these would have the same length after doing an overlay in this case. So they all have the attributes that they used to have, but now there's more of them. So that's a problem. Okay. When we do a union or an intersect, they create polygons for every possible combination, and so you'll have a lot of polygons in your output data set if you had a lot of overlapping polygons. What's the difference between union and intersect? Anybody remember from last semester? From the last time you took the course? GIS operation.
Unions where you just merges them together, and the intersect is where it's just the spots where they hit overlap.
That's right. So an intersect and a union differ in terms of what will be present in the output data set. However, they do the exact same thing in terms of the attributes.
Is it that union still continues to show you everything, but intersect only shows you the things that all match up together?
Right.
Okay.
So you could actually do, like let's say you had a GIS that only did a union. You could actually answer all the same questions. You would have to do the union first, then you just select out any areas where there wasn't an attribute from all of the input data sets. Then your output would be the same as doing an input. So a union is really the only overlay tool that you need in a vector data set, but you'll have to do some extra table manipulation without having a separate tool like intersect. Let's look at this. There's the other data set that I wanted to look at. All right, PLS.
Okay, so it won't keep, I see on the PowerPoint that the intersect only keeps polygon for 3 or more sources overlap, so if even if you do 2.
Where is that?
The next slide. Is that just for this?
That's just for this example.
Okay.
Yeah, so in this case, if you intersected these 3 layers, they all have to be present for them to be present in the output data set. So this works actually really well. It's common in this case where we're doing like, we're trying to identify habitat and we're saying, okay, this particular snail needs to exist in dense conifer areas. It needs to exist in limestone soils, and it only has a certain elevation range. All of those together say are the criteria, and we're going to do an intersect because they need to meet all of those criteria. Okay. All right, so let's say this is what we're going to do for the lab. Let's say that I have these public land survey grids. This is the township and range system. I'm going to put this layer on top of that layer. And I want to find out how much water exists in every single one of these township and range boxes. Okay? How could I answer that question? Well, I could do an overlay that would clip out the polygons and create new polygons wherever there was a border. So let's do that. Let's do it first as a union and then as an intersect. So I've got union. My input features are going to be the dissolved water bodies and the PLS data set. Now, eventually what I'd like you to do is combine the PLS data sets from all 3 counties. But we're just going to do it for this one. All right. Plus, you'll see it'll create an interesting thing here. All right, so I'm gonna intersect these 2 data sets. This is just, I'm gonna call this this output whatever it's gonna put plus union. I'm just gonna call this union test. Okay, I'm gonna have it join all the attributes. You can alternatively go in here and say that you only want to do the feature ID attributes, but I want all the attributes. I'm going to run it, and I'm going to turn off the other layers just so that we don't think any of these other data sets are coming from there. Right now, when I zoom in here, look, because it's a union, it got all these other lakes out here. Okay, but we also split this into 1, 2, 3, actually 3 because there's no public land survey out here. So we split that into 3 different polygons. That one's not on the border. But anytime we get one on the border, some of these are really, really close to the border. Anytime we get one on the border, so that it was split now into 2 polygons. Now if I look at the attribute table for this union data set, I will get all of the attributes in both data sets. So if I select, let's select just this guy right here. I selected that guy. I'll look at him. Select just that one. So now I can see that that's in Forest County, and it has all the attributes of the PLS data set. So let's see what the, looks like the PLS ID, the township and range was 45, or sorry, no, the range, the section was 28. So I've got all that information from the township and range data set, plus I've got all the information from the water body data set, which was actually just 2 sets of information. So combine those 2. All right, I'm going to remove that. Now I'm going to do an intersect of the same data set. Intersect of the same 2 data sets. So I need the water bodies, I need the PLS data, and I'm just going to call this intersect test. All attributes, and I'm going to run it. I'm going to change this different color, like this blue. Now you can see that it only exists where both of the input data sets existed. So now if I zoom into this little guy, and select, not select, I want to do input, identify. So I'm going to identify that guy and look at the attributes. Look at the shape, 7, 8, 3, and all the attributes. I wish I could, oh here, I could go like this. Snipping, tools. I want to get rid of this guy, and I want to click on the same one there. Okay. So those 2 polygons should be almost identical. The only difference is the object ID, which is just generated by ArcGIS. Okay? But all of the other attributes are exactly the same. There are no differences between all of these attributes and all of the equivalent attributes. Okay? And the reason why is that union and intersect do the same thing. They just don't include these polygons out here that didn't exist in both data sets. We could select out those data sets by, see look, FID NH water body is -1. So I could go select by attributes and say, I want to find, whoops, I want to go into union test, create a new selection. I want to say all of those areas that do not equal to -1. And what that does is select out just those that were in the intersect. So if I save this out, it would be functionally equivalent to this data set. Not exactly because of these things, but I could remove those in a different way. Okay. All right, so that's union and intersect. It combines all the attributes of the data, and it creates new polygons at the borders. Any border that exists becomes a new polygon. Now, you can overlay, I've been talking about polygons. You can overlay points and lines, but it will always yield the smaller of the spatial dimensions. So if you overlay polygons and lines, you'll get lines. If you overlay lines, you'll get lines. If you overlay lines and points, you'll get points. All right, so here's just a graphic example of doing an intersect, doing a union, doing a clip, and doing an erase. One of the things you really have to look for, one of the problems with doing an overlay is you get lots of slivers in your data, especially if your data is misaligned. Okay. If you look at the union tool, you can change the tolerance value, which what that will do is if any object, if any of the new features is smaller than a certain size, it will remove that feature. The reason that that's an input is that it's different depending on your scale of analysis. If you're trying to do this for the whole United States, you might consider something the size of half of a county a sliver. In our data set, we've got really, really small lakes. We don't want to consider something this big even as a sliver, so we would just leave that 0, okay, the way that it came. So you need to be careful with the tolerance value that you use. So sometimes the slivers are real, and you need to determine whether or not it's basically a cartographic adjustment that you're making. It's not going to improve your data by removing slivers. Dissolve can be done with points, lines, or polygons as well. Right? So the reason I have this slide in here is that I also wanted to make you aware that when you do a dissolve, you also need to think about how the attributes are combined, just like you do with an overlay, because things like lengths don't automatically get updated here. And also, just because two streets, in this case, are next to each other, they may not all be called Main Street. In this case, they were, but there are cases where things change name or change any other attribute. So here's a dissolve. All right, here's a few other things to keep in mind when you do an overlay. Doing an overlay is actually fairly computationally intensive. If you have two very large data sets, you do an intersect or a union, it's actually not that hard. You get a couple million features in both data sets, and you can either look at your computer crashing or having to walk away and come back and see what it looks like in an hour or two. So what we've done have been fairly similar, but there are large data sets. You can think about what it's having to do mathematically is find those places where polygons intersect and then creating a new polygon with part of that polygon and the other part of the other polygon, and then taking all the data and putting them together. It's actually simpler to think about it in our head than it is in terms of the computation that's been going on. So it's often helpful when you're building models to actually do your queries or selections first, to take out any data that you can. So if you're going to do a select, you're going to select out some of your data, it's best to do that first, then do any overlaying operations. Okay. In that order, because your computations will be faster. You won't have as much to do in the overlay. Okay, let's go ahead and stop there. I'm going to